Alright, so in this problem, I have x to the power of x is equal to 2 to the power of 2048. So now the first thing I'm going to do is I'm going to write 2048 here as 1024 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 1024 times 2, I can rewrite as 2 to the power of 2 to the power of 1024. Now 2 to the power of 2, that's simply equal to 4. So now I have x to the power of x is equal to 4 to the power of 1024. And now 1024, remember how I rewrote 2048 1024 times 2. Now I'm going to rewrite 1024 as 512 times 2. So now I have 4 to the power of 512 times 2. And now I'm going to do the same thing. If I have something in the form a to the power of m times n, that's equal to a to the power of m to the power of n. So this is equal to 4 to the power of 2 to the power of 512. And 4 to the power of 2, that's simply equal to 16. So now I have x to the power of x is equal to 16 to the power of 512. And now I'm going to do this again. So now I have x to the power of x is equal to 16 to the power of 512. That's the same thing as 2 times 256. And again, this is equal to 16 to the power of 2 to the power of 256. And 16 to the power of 2, that's simply equal to 256. So now I have x to the power of x is equal to 256 to the power of 256. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. However, this is only true if b is greater than or equal to 1. So in this case, as you can see, a would be x and b would be 256. And is 256 greater than or equal to 1? Yes, it is. Meaning, we can write this in the form a equals b. So x is equal to 256. So this is my answer. Alright, so for this problem, I have x to the power of x is equal to x to the power of 2. So, to solve this, I'm going to first start by dividing both sides by x to the power of 2. So then these two cancel out, and now I'll be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, can rewrite that as x to the power of x minus 2. And this is equal to 1. Now, if I take the natural log, or ln, on both sides, I get ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can actually move this exponent of b to the front. So this can equal b times ln a. So for ln x to the power of x minus 2, I can move x minus 2 to the front. So that's going to equal x minus 2 times ln x, which is equal to ln 1. Now ln 1 is simply equal to 0. So now I have x minus 2 times ln x is equal to 0. So this actually gives me two equations. I have x minus 2 is equal to 0, and I also have ln x is equal to 0. So for x minus 2 equals 0, all I have to do is add 2 on both sides, and I get x is equal to 2. So this is one solution of x. Now for ln x equals 0, I'm actually going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. Now e and ln, these two simply cancel out. So for my left-hand side, all I'm simply left with is x is equal to e to the power of 0 is 1 because anything to the power of 0 is 1. So I have x equals 1. So these are my two solutions. So now to check, I had x to the power of x is equal to x to the power of 2. If x equals 2, I have 2 to the power of 2 equals 2 to the power of 2, meaning 4 equals 4, so this is right. So x equals 2 is right. Now if x equals 1, I have 1 to the power of 1 equals 1 to the power of 2, 1 to the power of 1 is 1, 1 to the power of 2 is 1, so this is right as well. Alright, so in this problem, I have 5 to the power of 12 times 4 to the power of 5. So to solve this, I'm going to first rewrite 4 here as 2 to the power of 2. So now I have 5 to the power of 12 times 2 to the power of 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 5, that's equal to 2 to the power of 10. So now I have 5 to the power of 12 times 2 to the power of 10. Now, 12 here I can rewrite as 2 plus 10. So now I have 5 to the power of 2 plus 10 times 2 to the power of 10. Now, if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So 5 to the power of 2 plus 10, I can simply rewrite that as 5 to the power of 2 times 5 to the power of 10. Now I have this times 2 to the power of 10. So now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So in this case, I have 5 to the power of 10 times 2 to the power of 10, and that's going to equal 5 times 2 to the power of 10. So 5 times 2 is simply equal to 10. So now I have 5 to the power of 2 times 10 to the power of 10. Now, 5 to the power of 2, that's equal to 25. So now I have 25 times 10 to the power of 10. And 25, that's the same thing as 2.5 times 10. So I have 2.5 times 10 times 10 to the power of 10. And 10 times 10 to the power of 10. Well, 10, that's the same thing as 10 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, that's equal to a to the power of m plus n. So 10 to the power of 1 times 10 to the power of 10, that's going to equal 10 to the power of 11. So I have 2.5 times 10 to the power of 11. So that's my answer in scientific notation form. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have a to the power of a is equal to 2 to the power of 8. Now 8, this is the same thing as 4 times 2, right? So now I'm going to write this as a to the power of a is equal to 2 to the power of 4 times 2. And now, if we have something in the form a to the power of m times n, we could write this as a to the power of m to the power of n. Or we could also write this as a to the power of n to the power of m. doesn't matter the order because they're both being multiplied, and multiplication order doesn't matter. So now I'm going to write this as a to the power of a is equal to 2 squared to the power of 4. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this would equal 2 to the power of 2 times 4. However, I am not going to do that. I'm simply going to solve what's in the parentheses. So 2 squared, and that is equal to 4. So now I have 4 to the power of 4 is equal to a to the power of a. Now, if we have something in the form x to the power of x is equal to y to the power of y, and this means that x is equal to y as long as x is greater than or equal to 1. So in this case, a is equal to 4.